Hello and welcome to our special session on taking action to adapt to climate change. I think we're all aware that climate change impacts on natural and managed systems are significant. This has been well documented over the last decade, indicating we have an urgent need to act by implementing adaptation strategies and tactics. Over the last several years, federal and state agencies and conservation organizations have all identified a variety of climate adaptation approaches using different tactics and scales. However, many practitioners have struggled with how best to incorporate climate change information and projections and what actions to undertake. This session will offer some insight into different organizations' approaches to climate adaptation, highlighting several case studies by leading practitioners. Each presenter will discuss the innovative approaches that they have taken, challenges they have faced, lessons learned, and at the end, we will have identified a set of parameters for success in climate adaptation efforts. Session participants are encouraged to engage with our practitioners and with one another across all of our organizational boundaries so that we can increase the rate of adaptation to climate change. You know, the time to put action on the ground is now. So let's get started. I think we all recognize that climate change has been well documented. What is happening, what the trends are, what the impacts are. I think we all understand the real risks to our different resources. Water quality and quantity, habitat, recreation, cultural resources or vegetation, etc. The science is clear, and the change that we once predicted 20 years ago, 10 years ago, is happening now. Our key indicator to climate change is changing temperature. Increasing temperature is driving the change that we see across our landscapes. The effects differ across the country, whether we're talking south to north or east to west. And the effects are evident as we see more frequent and severe disturbance events. Drought stress increases our vulnerability of our forests and rangelands to insects and disease, increases the likelihood of bigger and hotter fires. Storms are becoming more frequent and severe, causing widespread flooding. You know, the 100-year flood zone is probably a thing of the past as we know it in many places. Just think back to last year, 2020. Record year in intense tropical storms and hurricanes in this country, a record year in fires across the West. We have the science knowledge. So what can we do to mitigate the risks from climate change? Over the last decade, in many of our organizations, we've all developed processes to interpret science and identify adaptation strategies. Step 1 and 2 in our Forest Service processes. But you know, it's really difficult to integrate and implement this on the ground because it feels risky to abandon the tried and the true management practices and silvicultural treatments that have been in practice for many decades. So we have applied different science and management partnerships and engagements to get after and to identify those likely strategies to adapt, actions to take that can be successful. But how do we really move from planning and engagement and talking about it to action? This is particularly difficult for public land managers. So we have developed and applied then many various frameworks to transfer that technical knowledge from across the science to the management community, Bridging that gap. This one may look familiar to some of you. This is a decade old. Our focus has been on developing the adaptation options for the past 10 years. Now we need to find a bridge or build a bridge of the gap between a plan and taking action. Let's examine the problem through a technology transfer or adoption lens. Technology adoption research suggests that highly complex science applications or technologies need to be communicated directly from an expert to a user to reduce the risks from trying something new or novel. We also know that innovators and early adopters differ from later adopters. And it's important to identify these individuals and organizations for engagement because they are key to moving more quickly to action. And finally, we know that influencers or opinion leaders who demonstrate or trial adaptation tactics, techniques, practices on the ground are more likely to be followed by others. You know, the average time from a research discovery or development to an application and to adopt that application is 10 years in government. I'm going to suggest that we probably don't have 10 more years to wait before we take action to address significant risks from climate change. We can close and shorten this gap. We can do it by identifying the problem and helping others see how that problem affects their interests. We need to talk to people directly. The direct communication between the experts and the community at risk is really important. We need to collaborate. You know, we need to cross our boundaries, put together collaboratives, and create a community to support and lead change. It's hard to be the only one stepping out there. Bring some friends along. We need to be innovative. We need to take a chance because I will suggest that by doing nothing, we are assuming a great deal of risk to our landscapes. And finally, we need to lean in on influence. We need to go from trial to practice. We need to highlight and get the word out of success from our leaders, our innovators, and our early adopters. All right, let's get started. Let's create our own sustainable future. You know, I like to share with people how I have worked in this field for more than 2 decades. And many years ago, thinking about the future and climate projections and the uncertainty out there and what is going to happen, what does the future look like? When we were talking about 2100, it seems so long ago. But today, when I think about it in terms of my own family, I realize that my granddaughter will be 84 in 2100, and my grandson will be 82. And what I see, the risks that are occurring out there to their future, to the sustainability of our resources, it scares me. So it's time to take action, and we will learn from our actions because we know what inaction will result in. Let me introduce you to our panel. Dan Isaac is a researcher at the U.S. Forest Service Rocky Mountain Research Station. He's going to talk about his new and novel way of crowdsourcing to develop climate information and user community engagement. Remember, let's get together. And then Matt Vasquez and Paul Jones are going to be talking about the application of that model I showed you 10 years ago in the Gunnison Basin and applying what they learned in an adaptation strategy to wet meadow restoration. Marv Brown from the National Association of State Foresters will share with you from a state level how state forestry action plans are addressing climate change and where adaptation leadership is coming from and where we can lean into. Martin Lowenfish and Tim Griffiths from NRCS are going to share their model for success, Working Lands for Wildlife, a landscape approach to taking action and building climate resilience across private lands. And finally, Maggie Ernst Johnson from Association of Fish and Wildlife Agencies. We'll talk about success in working across those boundaries. It is so necessary to create the community of action takers and permissions to take those actions. Thank you very much.
Hello, this is Dan Isaac. I'm a research fisheries scientist with the U.S. Forest Service Rocky Mountain Research Station. And I want to thank Cindy West for organizing this session and inviting me to participate here at the Wildlife and Natural Resources Conference. And so I'm going to talk a little bit about crowdsourcing and how we've used that as kind of a new technique to engage a lot of different groups in the science that we're doing. And in the same process, then develop some high resolution climate scenarios and species distribution models that are useful for prioritizing and adaptive learning about where it is that we're going to invest our conservation resources this century to preserve aquatic species in many parts of the Western United States. And so everything we're doing is just kind of motivated by the basic warming trend that we've been seeing globally now for many decades. And we're expecting that this is just going to continue for the foreseeable future, even if we were to turn around and be entirely powered by green energy tomorrow. There's still a lot of warming baked into the cake. So we've got to find ways to develop good spatial high resolution maps about climate scenarios for streams and how that impacts biological organisms that we're concerned about across many of the lands that Forest Service plays a role in managing. The good news is that there's always a lot of things that we can do to improve habitat and improve the resilience and resistance of some of these species that we care about. The biggest challenge for us, and this was true even before we started worrying about climate change, was just prioritizing and figuring out where to allocate our limited conservation resources so that we could have the biggest bang for the buck. And it's the case then that as we think about different species, not all species are at equal risk from climate change, nor even within an individual species are all the populations of that species at equal risk. And so some might be currently existing within a big, robust habitat that's likely to serve as a long-term climate refugia. And if that's the case, they're probably going to be okay, and maybe there's not a lot we need to do to bolster that population. Others, may be kind of at the margins of a place that might decline dramatically as it gets to be warmer, and so those might be places we want to invest. And so everything we want to do then is tied to trying to tease that out and think about where on the landscape we should make these investments. The challenge here is that we need to have high resolution climate and biological information across really broad areas and multiple agency jurisdictions. And traditionally, that sort of level of information has been not exactly what the climate models have provided, which typically have really big grid cell sizes, on the order of dozens or hundreds of kilometers, and that's just orders of magnitude bigger than the individuals within the populations that we're trying to manage. So one of the things that we've realized is that to get that additional resolution we need to have a lot more observations taken on the ground, and we need thousands of those a lot of times, and that's just beyond the scope of what we can do as researchers within the Forest Service, or even researchers partnering with other researchers. So for us, it's been a really useful and powerful thing to learn how to build bridges with citizen science groups and management biologists across many different agencies. And the thing that's enabled us to do that then is just the fact that many of the types of data that we want to collect a lot of times are similar across different agencies and across interest groups. And it's also the case now that standardized protocols exist for collecting those types of data. And so that allows us to hand something off to someone that sets with a set of instructions and a data collection instrument that's pretty straightforward. They can collect the sample and then report it back to us so that we can include that observation then in a large data set. And so just as an example of this then, one of the things that we needed in stream science and climate prioritization for aquatic species was high resolution stream temperature scenarios rather than having to rely on relatively coarse air temperature scenarios. And so we needed to develop our own scenarios with lots of stream temperature observations so that we could downscale climate and climate change to what's going on within river reaches across networks. And so what we found once we started diving into this problem was that there's a lot of data that a lot of different agencies are already collecting. And the problem wasn't necessarily that we didn't have enough data, it's just that we hadn't organized it into one central database that made it usable and made it as a resource that was available to everyone. So as part of this Norwest project, we built a database team and then essentially contacted dozens of different state, federal, tribal, and private agencies across the western United States, got copies of their data, put it into one database, and then we fit a model to it so that we could interpolate amongst the observation locations and make predictions throughout all the perennial rivers and streams of western United States. And then we've got now our high resolution climate scenarios that we were lacking before. And we can use that information then with equally large observation data sets of species occurrence that many state agencies, universities, federal agencies collect. And so here again, we could reach out to our partners, pull in their biological data, link it to these stream temperature scenarios, start to describe thermal niches for some of the species that are common in the western United States, and identify then a few of those that seem to be particularly sensitive to climate warming. And in this case, we looked and we saw that both cutthroat trout and bull trout have really cold thermal niches, and they're the sort of species then we thought might be especially sensitive to climate change. And so once we'd done this preliminary screening, we then took this the next step of basically just building a more accurate and precise species distribution model for these two particular organisms by adding in additional data, additional covariates, and making statistical relationships then that allowed us to map out at a high resolution across the entirety of the species ranges for these organisms the probabilities that they would exist under current climatic conditions as well as future climate conditions. And so what we see for an organism like bull trout, and I'll flip between scenarios here for them, is that because it requires a lot of cold water, as it gets warmer, we're expecting that their populations are going to shrink and be forced up into the headwaters. But at the same time, even under an extreme climate change scenario like we're representing here in the 2080s, we have a lot of streams that still have a high probability of supporting local populations. And so these can act as functional climate refugia. And by communicating that then to the managers on the landscape, that they've got a special stream on their national forest or on their ranger district, that then allows them to plan around it and maybe take a little bit better care of it than they would have otherwise. And so to go that last step and make the information usable for them so they can incorporate it to their on-the-ground planning, we'll typically build customized websites to deliver the science outputs from these models. And we do that in formats that are easily usable by the end users as PDFs and ArcGIS shapefiles. And what we found is that by providing the information to people in a format they can use, as well as including them on the front end by allowing them to participate in the data collection efforts, they have a lot of ownership in these projects, and the information comes to them at a scale that's useful. And so they can combine it with everything else they know about these landscapes to then identify how and where it's going to be best to prioritize where they do conservation for particular species in the streams that they're familiar with. And so this is just kind of a model now that we've adopted for working with lots of different species, for working with stream temperatures, and it just kind of creates a virtuous cycle of continuously updating, building databases, and providing information to the ground users in formats that they like and think is very useful for their purposes. And so, getting to this point required a little bit of adaptive learning on the part of scientists, because rather than a traditional science model where it's just, you focus on what you're doing, you publish a paper and you hand it off, we had to kind of broaden our horizons here and engage with managers and citizen scientists in the public to have them be part of our data collection and also our output vetting process. And doing this sort of science also requires, kind of having a team of people with technical skills too. So it's not, something that everyone can do. But as long as you've got access to people with those technical skills, you get the standardized procedures for collecting these sorts of data sets. And then, it gets to be really powerful to build this synergy among different groups. And I think that's all I've got. And so hopefully I didn't run too long. And if there's time for questions, I'll be happy to take them. Thank you.
Hello, my name is Paul Jones, and I'm a contractor with the Upper Gunnison River Water Conservancy District Wet Meadow Restoration Resilience Building Project. Matt Vasquez is one of our primary project partners at the U.S. Forest Service, and he developed this presentation for last year's conference. Unfortunately, a promotion has prevented him from being able to allocate the time to present this year, and he asked me to present in his stead. So on behalf of the Gunnison Climate Working Group, thank you for the opportunity to tell our story and share what we've learned with you. One of the management challenges we face is how do we build ecosystem resiliency? Rising temperatures and associated temperature-driven ecological changes, wildfires, drought, invasive species, and weather extremes are contributing to a rapidly changing conditions, affecting nature and people. In southwestern Colorado, we're focused on climate adaptation, keying in on drought resiliency, water flow regime, and native plant species diversity. This presentation will cover the impacts that we are addressing in our strategy, why we want to restore wet meadows and what's at risk, the restoration goals, restoration methods, techniques, and examples of on-the-ground work, monitoring results. We want to share our successes and go over some of the lessons we've learned. First, we want to acknowledge all of our partners who make this possible. The Wet Meadows Restoration Resiliency Building Project is a collaboration of more than 30 different organizations now, ranging from individual landowners all the way to volunteers, state agencies, and universities. The driver that brought this unique group of people together is the Gunnison sage grouse and its conservation, and the motivated people who care deeply about the bird and what it represents: the sagebrush ecosystem, sagebrush-dependent species, ecosystem services, land-based livelihoods. We've convened around the common cause of restoring habitat for the threatened Gunnison sage grouse. Since 2012, we've worked to improve wet meadow habitat riparian areas and the resiliency to drought on public and private lands using funds, labor, and assistance from many sources. This raised awareness for the need to implement actions to increase ecosystem resiliency, but driven by a desire to help the Gunnison sage grouse and all it represents persist. The Gunnison Basin is a high-elevation mountain valley in southwestern Colorado. Elevations range from about 7,700 feet down near town all the way up to 14,000 feet on the Continental Divide. It's a 2.5 million acre landscape, 85% of which is public land that's managed by the U.S. Forest Service, the Bureau of Land Management, the National Park Service, the Colorado State Land Board, and Colorado Parks and Wildlife. About 23,000 people live in the basin, which is comprised of portions of 3 counties: Gunnison County, Hinsdale County, and Saguache County. With the Nature Conservancy initially leading partnership coordination efforts beginning in 2011, and based on the results of the Gunnison Climate Change Vulnerability Assessment, which identified wet meadows, riparian areas, and Gunnison sage grouse as vulnerable, we chose to develop a climate adaptation and resiliency strategy for the Gunnison sage grouse and wet meadow habitats in the sagebrush ecosystem. Here are the impacts that we are concerned about, and these are the strategies we are using to address those impacts. Increasing temperatures, more frequent weather extremes, including drought, less precipitation in the form of snow, increased precipitation as rain, which causes intense runoff events, and reduces the amount and quality of wet meadows, which leads to erosion, and which in turn causes soil and plant loss, reducing food for sage-grouse, which is critical for chick survival and population recruitment. I'd like you to think back to the first slide we had in this presentation. It was a photograph of a whole bunch of Gunnison sage-grouse foraging in a wet meadow, which is actually a buffet of insects and forbs for the species. This is why restoring wet meadow habitats matters for Gunnison sage-grouse. For the first 2 months of their lives, chicks are eating arthropods, typically crawling insects like beetles, spiders, and ants. Wet meadows are good habitat for this high-protein diet, which chicks must have to survive. Maintaining, restoring, and enhancing these music sites may contribute to higher chick survival, which in turn relates to population recruitment. These are also important areas for ranching and grazing permittees. They are used by livestock for forage and water. Collectively, this is in alignment with the multiple use mission of the Forest Service and the Bureau of Land Management. As you can see, there's a very direct and clear connection to the restoration of wet meadow habitats in Gunnison sage-grouse. And our goal isn't just Gunnison sage-grouse, but it also integrates other wildlife and ecosystem services as well as people. I'll read you our project vision, which describes the desired condition we are working towards. Natural wet meadows and riparian habitats within sagebrush landscapes of the Upper Gunnison Basin are resilient and support sustaining populations of Gunnison sage-grouse and other species, biological communities, ecosystem services, and the livelihoods in the face of a changing climate. Sustained and long-term community commitment to stewardship of wet meadows and riparian areas helps nature and people adapt to a changing climate. This is a photograph of a plug and spread treatment. The plug and spread is essentially a structure that plugs up a gully that should not exist and is outside of the natural channel and dispersed flow. It restores that dispersed flow to the historic wet meadow. The photo on the right is an example of the restored dispersed flow on the historic meadow from the plug and spread treatment. You can see dead sagebrush that's a result of increased moisture in the wet meadow. This benefits one of the primary constituent elements of the critical habitat designation for Gunnison sage-grouse, mesic habitat within breeding habitat. This is an example of wet meadow habitat, the sponges in the sagebrush ecosystem. We key on our riparian meadow habitats to essentially remodel those mesic habitats by implementing simple but effective restoration techniques to increase resiliency to drought, heavy runoff events, and at the same time consider other management activities and influencing factors on the landscape that might increase mesic habitat vulnerability. Precipitation, another important factor, can be highly variable in the semi-arid climate of the Gunnison Basin and throughout the range of the Gunnison sage-grouse. We rely heavily on these simple yet effective techniques. We pull these directly out of Bill Zedike's toolbox. We use rock structures, the One Rock Dam, the Media Lunae, the Zuni Bowl, rock rundowns. We use log structures like the log and fabric structure. We also use behavioral structures like drift fences. And then we have our earthwork, like the plug and spread or contour swales that are built with heavy equipment. This slide represents the evolving cross-sectional profile of an eroding slope wetland. As the gully deepens, flow rates accelerate, and as those flow rates accelerate, energy increases and the ability of water to carry more soil increases, and the gully gets deeper and deeper. The primary grade control structure that we use is the simple One Rock Dam. It's a low-grade control structure built with a single layer of rock on the bed of the channel. One Rock dams stabilize the bed of the channel by slowing the flow of water, increasing surface roughness, recruiting vegetation, capturing sediment, and ultimately raising the bed level over time. Most of our restoration structures are one-rock dams. We also use vegetative grade control structures, like the beaver dam analogs that have been detailed in the low process based restoration of riverscapes design manual that you can get out of Utah State University. This is an example of a media luna, or half moon. The media luna is designed to spread water out across the floodplain, restoring sheet flow. Both of the photographs taken by both Betsy Neely and Renee Rondeau show the effect that this structure has had over time. Zuni bowls are built to control large head cuts. It creates a temporary pool of water. It's composed of rock-lined step falls and plunge pools that prevent head cuts from continuing to migrate upstream or upslope. Here is a description of the plug and spread structure that we talked about earlier. Like I said, it's used to restore dispersed surface flow to gullied surfaces and increase infiltration, thus recharging shallow groundwater resources. Typically, it's used in gullies that are 6 to 8 feet deep, and it's constructed with a plug that fills the gully bottom. The material that's used to build the plug comes from what we call the bay, which lays back in the wet meadow. The brim of the bay is designed to be level with the surface of the wet meadow so that the water that collects behind the plug flows evenly out across the entire surface of the meadow. Before one can start building structures, you have to learn to identify the problems. You have to understand why we're in the situation that we're in. It's imperative that you learn to read the landscape and to understand how water moves through it. It's also important to understand how water moved through the system before it was disturbed. It's critical to understand the causes of the erosion, because understanding those causes allow us to be able to figure out the best way to fix the problem. After we've done that basic analysis, we return to the site and begin to design treatments. We start to stake out the structures so that we can plan for the quantities of rock and figure out how we're going to get it into where we need it. If you're lucky, you may have an abundant source of rock nearby and you may be able to gather rock on site. However, we have found that many of the sites that we need to work in, we don't have a nearby source of rock. Sometimes we go to extremes to move rock. In the fall of 2018, the Rocky Mountain Region Mule Pack Stream hauled over 30,000 pounds of rock over a 7-day period. Very often we use UTVs like you see in the bottom left photo, and sometimes hand crews are used to haul logs for our log fabric structures into the sites where we're building the erosion control structures. To date, we've relied heavily on volunteer and youth crews, including the Forest Service YCC crew and the Western Colorado Conservation Corps crews, to complete the work. This is an important investment, resulting in long-term sustainability by building the capacity to increase restoration. WCCC and the Wildlands Restoration volunteers are key partners and who are instrumental in engaging youth in conservation work and recruiting volunteers, building community involvement, and creating volunteer base that has built hundreds of restoration structures. Perhaps the most important part of our project is our vegetation monitoring. This allows us to know if our project is working. Are we making progress in meeting our objectives? So we use a stratified random design, a line point intercept method, on 217 transects, including 52 controls. We also have 500 permanent photo points. Again, our objectives are to increase the cover and density of wetland plants like sedges, rushes, willows, and wetland forbs, and decrease the cover of upland species in these wet meadow habitats. This slide shows the overall trend in wetland species cover for 10 stream reaches in the Gunnison Basin. Wetland species cover increased significantly in the treated areas compared to little change in the untreated areas. The numbers near each point refers to the number of transects in that reach. Renee Rondeau of the Colorado Natural Heritage Program applied a t-test assuming unequal variances on the slope of each transect. Basically, did wetlands cover go up or down on any given transect compared to the untreated areas? This data validates our treated areas have a positive trend and are gaining wetland species cover compared to the untreated areas. This is a head cut control using the log and fabric structure. This head cut had migrated some 85 feet in a little less than 20 years. In August of 2013, we built the log and fabric structure, and we have watched as significant aggradation has increased in this arroyo since the construction took place. Some of our most important structures have nothing to do with geomorphology or hydrology. Drift fences change animal behavior. Drift fences do not exclude cattle or wild ungulates from accessing forage, but it does shift their trailing patterns more into the uplands and out of the sensitive wetland areas. We have found these structures to be incredibly important. Since 2012, we've built nearly 2,000 structures on 7 miles of stream. We estimate that we've improved about 1,260 acres of sage-grouse habitat and approximately 181 acres of wetland habitat. This has been done with hundreds of volunteers, YCC crews, and students. What's kind of exciting is that the Natural Resource Conservation Service adopted our practices, and here in Colorado they issued a technical note, and they've incorporated our work into their regular work throughout all of their offices. And this document can be accessed off of our webpage as well. We continue to export the technology through knowledge sharing, and we hope to dramatically scale up our projects in the next few years. I'd like to close with a quick summary about things that we've learned along the way. You know, we've learned to embrace change. We've learned that if we take the time and do the right analysis, we can manage for future conditions. We've learned that partnerships and collaboration are absolutely essential to the project's success. This is not something that can be done by one agency or one individual in an agency. You have to have capacity. And the only way you do that is by having champions within each agency and champions on each project. But with that, you can build a sustainable and enduring program. We think that it's absolutely essential that we ensure that we have scientific rigor through our monitoring. We're able to document statistically our responses. And then we continue to learn and adjust as practitioners. Constantly learning new things, we're always looking to add new tools into the toolbox. I'd like to close with a statement from Bill Zedike. When we were in the field, he turned to me and he said, "Look, Paul, these systems start getting better when they stop getting worse. So just start." That's the thing. You can start small, the risks can be low, and the rewards can be high. But you do have to start. Thanks for your time.
Hi, my name is Marvin Brown. I'm a former state forester and current contractor to the National Association of State Foresters, where I work on a variety of issues, including climate change. And I'm pleased today to give you a glimpse of how state forestry agencies across the country are developing and implementing strategies that provide for adaptation and mitigation to climate change. To do that, I looked in their forest action plans. Forest action plans were first required through the forestry title of the 2008 Farm Bill. It said that state forestry agencies will develop forest assessments and action plans every 10 years. The first were completed in 2010. The second versions of those are currently just now being completed or are under review. And I think it's important to note that all of these forest action plans are required to address national priorities that are conserving working forest landscapes, protecting forests from harm, and enhancing public benefits from trees and forests. When it comes to addressing climate change in their forest action plan, I think it's important to recognize that state foresters work for governors, and those governors represent a very wide political spectrum, and that climate change is still somewhat of a political topic. So you'll see how they talk about climate change in different ways. Some use the words climate variability. Others talk about the need to maintain forest resilience. Very few of them will come right out and say global warming, but some do. But still, in nearly every state, in their plan, there is pieces that deal with climate change. I looked at 3 states, one on the East Coast, Florida, one on the West Coast, Washington, and then one in the middle of the country, Minnesota. And again, it's important to say that some of these states, their plans are still under review, but I think what's in their plans in terms of strategies for mitigation and adaptation represent a really good cross-section of what you're going to find across the country. So in Florida, a concept that comes across loud and clear is that this climate change is not just an ecological issue, but it's a people issue. There are risks not just to forest environments, but there's risks and costs to human health. And keeping that in mind as they develop strategies, I think, is a really important concept. Accurate information is going to be extremely important in adequately dealing with this issue. Need to be able to predict what climate change how climate change is going to occur, what its impacts are going to be. Need to be able to model how vegetative communities are going to change, how weather events are going to change. So accurate information is extremely important. And at the same time, need to understand that active management is still going to play a very important role in dealing with climate change. That is, whether it be reforestation, thinning, harvesting, there's still a very important role to be played here by actively managing forests to address the needs for mitigation and adaptation. Not only should the information be accurate, but it needs to be shared with other members of the resource management community, other members of the scientific community, other members but also with the public and with the people who provide information to the public. That accurate information needs to be well understood across the spectrum. And it needs to be used to prioritize where work needs to be focused in order to effectively deal with climate change. They say here prioritize conservation of forested areas adjacent to identified susceptible communities, which could be things like coastal areas where soil salinity is going to change because of rising seawater, sea levels. Another important concept, if typically southern climates are going to migrate north, species, both floral and fauna, are going to need to be able to migrate with those changes. And in order for them to migrate, landscapes need to be connected. A very important concept that will be reflected, I'm sure, in a lot of different forest action plans across the country. There's very few private forest landowners, I'm talking about family forest owners primarily, who at this point understand the role that forests play in sequestering carbon from the atmosphere, and also the opportunities that may exist in the future to sell that process, to sell carbon sequestration from their lands to interested carbon markets. So state forestry agencies educating landowners is in their wheelhouse. It's going to be an important role to play, and using that role to inform landowners about the potential that forests have for dealing with carbon sequestration is going to be really important. And at the same time, it's not just going to be a rural forest issue. Urban forests are going to have a very important role to play as well. You know, tree canopies in urban areas help mitigate the heat effect that densely developed cities create. Also, you know, weather events are going to be more extreme with more intense rainfalls in shorter periods of time. Then the ability for forests to moderate storm runoff becomes very important. And urban forests can also be another player in the sequestration of carbon. So all very important. Looking at Minnesota, one basic concept here that we probably all know, but maybe don't always vocalize. The causes of climate change are certainly global in nature, but their impacts are local, and that's where we have to focus our energy. If we're going to promote forests as a way to sequester carbon, we need to have really accurate ways to determine just how much carbon is being removed from the atmosphere and be able to monitor how that removal may change over time as the forest itself evolves and changes. We talked about landscape connectivity. We've got to work at landscape scales to do that. And we talked about retaining active management as part of the solution. We need to understand just exactly what different management practices produce in the way of positive effects in dealing with mitigation and adaptation to climate change. Biofuels has been somewhat of a controversial topic, biofuels to replace fossil fuels. But I think the most encompassing view would say that within a large landscape area that is sustainably managed to pay attention to all the things that we want to pay attention to, like biological diversity, watershed health, healthy forest markets, within that kind of sustained environment, biofuels can certainly play a place to help offset some amount of fossil fuel consumption. And at the same time, we need to think about the fact that if species are going to change in a particular area, for example, if a traditionally aspen predominant area of the state is going to gradually shift to become more of a white oak sugar maple forest type, then how can we help markets migrate into using those new species? Because markets are one critical component of being able to maintain healthy forests. Nursery managers and reforestation managers understand that a white oak genotype suitable for southern Missouri is not the same white oak genotype that's suitable for central Minnesota. And as climates change in particular areas, the genotypes also need to change. And so that's going to be an important factor that needs to be dealt with at the nursery and reforestation level. Going on to Washington now, the West Coast start to pick up a flavor of some of the Western issues. Water is an important Western issue. And scientists there predict that both water quality and water quantity will be at risk because of climate change, and that needs to be dealt with. Interestingly, too, as they expect climate change to modify soils and modify vegetative cover, it's going to increase landslide risk. And landslide risk are an important public safety factor that also has to be considered when you're planning around this issue. Landscape scale, large scale connectivity. All that means that collaboration with a variety of stakeholders is going to be very important, so that folks gather around a common set of objectives and a common set of strategies for achieving those objectives. Acknowledging that there can be risks to water quality and quantity means that there has to be a particular focus on watershed health. What can you do to improve, maintain, sustain the health of a watershed and the different values that that generates? We all have witnessed this of late, but hotter, drier climates increase fire risk, increase fire activity, and increase fire damage. To mitigate that requires careful fuels reduction at a pace and at a scale that is going to keep up with the changing impacts from these changing climate conditions. Landscape scale, landscape connectivity, collaboration, that all means, again, we're going to be working across ownership boundaries to get those things done. Federal land mixed in with private land, mixed in with state land. Can we use different authorities, different tools in order to effectively manage landscapes across different ownership boundaries? That's another very important strategy. So that's just a very brief look at 3 states. I think there are 3 states that are representative of what you'll find in various parts of the country. I'd be happy to answer any questions when we get to the panel discussion, and hope that this has been informative. Thank you.
Hi, my name is Martin Lowenfish. I am the branch chief at area-wide planning at NRCS, and I'll be presenting today with my colleague Tim Griffiths, the West's Working Land for Wildlife Coordinator at NRCS. And as the title says, we will be talking about our landscape scale frameworks that we're developing to address wildlife, agriculture, and incorporate climate change into that approach. As many of you know, the climate change has been a key priority for the Biden administration, and for USDA, a lot of the way we'll be talking about climate change and climate resilience is going to be captured under the term climate smart agriculture. We have up on the screen a definition from the UN Food and Agriculture Agency that provides for the sustainability of agriculture itself. But if you look at the excerpt from the new climate EO from the Biden administration, there's an incredible focus on protecting and conserving the lands, waters, and biodiversity of the United States. This is not a new focus for NRCS, and the historic approach the agency has taken to conservation incorporates a landscape approach that is science-based, focuses on a landscape scale approach, and incorporates the leadership from local people and local producers. NRCS has incorporated this landscape scale approach in what we've called our landscape conservation initiatives, which have provided targeted funding to accelerate this locally driven approach and achieve measurable outcomes for clean water, wildlife species, and other resource concerns across the country. One aspect of the landscape conservation initiatives that many of you should be familiar with is the Working Lands for Wildlife approach, which is a broader approach, as I just said, rather than a funding source or a funding program. Again, the focus is to implement enough of the right practices in the right places to benefit populations, all based on strong science foundation, science that can incorporate the impacts of climate change. And to date, we've enrolled 7,400 private landowners, and they've conserved collectively more than 10 million acres across the country. Part of the success of the Working Lands for Wildlife approach has been the development of what we call investment strategies that provide a multi-year outlook on how NRCS is going to address or deliver the dedicated funding for these species across the landscapes, again, based on the science. But we recognize that taking a successful approach to the broad challenges, not just for wildlife, but to agriculture, takes a broader approach, and the science is behind all of these investment strategies. And that's why we're now taking a broader approach to bring the science and the conservation planning framework at a landscape scale more to the fore, and we are publishing these what we're calling conservation frameworks for biomes now across the West. And with that, I'll turn it over to Tim, who's going to talk about how these frameworks are developed and how they can incorporate climate change.
Yeah, thanks, Martin. When we were developing the new conservation frameworks out west, the first thing we did was try to put into context why we care so much about rangeland and why others should too. Quantified a lot of statistics like, did you realize 1 out of every 3 acres in the entire lower 48 is comprised of rangelands? Out west, that number's even ballooned up to 70% of all lands are composed of rangeland. 2/3 of those lands are owned by private landowners. And livestock grazing is the single land use that sustains this resource across the entire biome. Not only are these lands important for those local communities and for agri production, these are biological hotbeds. This is where hundreds of species make their living and why we need to focus on conserving it. There's also strong climate implications associated with rangeland. And we know that as we're trying to implement climate smart actions into Department of Agriculture, that Western rangelands can play a meaningful role there. When you look at carbon in rangeland environment, you realize that there's 2 components. There's a plant component and then there's a soil component. And if you divide the 2, it's not even fair. Soils win every time. It's about a 90% of the carbon is sequestered in the soils versus in the plants. And so going to climate smart mitigation, the #1 action science recommends is that we simply avoid conversion of grasslands and shrublands, or this ACOGs. And so goal #1 is keep grass green side up and don't allow conversion of those soils where those carbon that is stored is lost, as also the ability to store future carbon is lost. Aside from mitigation, we can also play a role in bolstering the overall resiliency of that rangeland, which then allows the land to adapt to changing environments. It allows the increased fire, the drought or deluge, all of these environmental extremes. It allows that land the ability to adapt, which is so important for both people and wildlife that depend upon it. Both of those actions are built into these frameworks. Frameworks also provide a working lands worldview. Again, recognizing that 2/3 of all of these lands are owned and operated by private agricultural producers, it's important that we work with those communities to ensure that the solutions that are created work for their private operation as well as the broader needs of the resource. And so, again, as Martin had mentioned, Working Lands for Wildlife operates in this sweet spot where we find intact landscape cores that overlap with important wildlife populations and also have people, have communities that are ready, willing, and able to act and move the needle on conservation in those landscapes. That's the sweet spot that we work under into Working Lands for Wildlife and is the heart of these frameworks. It's also important to recognize that these frameworks aren't a Lone Ranger type approach where we are out doing things that are in isolation. In fact, we are very much involved with broader partnerships that are working on much larger umbrella documents that can serve these very geographies. So, for instance, in the sagebrush system, many of you are familiar or have been working with the Western Association of Fish Wildlife Agencies on their new sagebrush conservation strategy, or in the Rocky Mountain Bird Observatory led the tri-national effort to conserve central grasslands through their development of a roadmap. Know that both of these new frameworks you can consider as NRCS's contribution to that broader regional plan. Very important concept. All of the frameworks also incorporate the latest and greatest in science and technology. This new science is available not only in peer-reviewed literature and journals, but also in spatial platforms that allow us to see and measure the world in new and innovative ways. Those findings then also allow us to develop unique approaches that at the heart foster a preventative care approach rather than emergency or ambulance type approach, where we are finding these intact cores and first and foremost maintaining and defending that core, and then we are growing the core and then mitigating impacts. In stark contrast to the way we've often worked, where we're putting out fires, sending ambulances to deal with emergency, we're trying to shift the entire focus from emergency to preventative care. Frameworks also are built on an incredible scientific foundation. And so there is a full scientific rationale and justification for everything that we are doing that is embedded within the framework. And in fact, when you get the PDF copy, you'll be able to click, like here, the superscript number 1, and it will go to the companion online resource so you can just learn not only where that reference is found, but it'll give a little bit of text to put that piece of science in context, and then it'll have a link to the actual peer-reviewed publication. So again, heavily referenced, but it's written in a way that can be consumed by all folks and stakeholders that want to use these frameworks. So let's take a deep dive into the Great Plains grassland and look at how all of this comes together. On the right, you're going to see a figure that was put together by one of our science partners, Dirac Twidwell, at the University of Nebraska-Lincoln, and he was using this new resource that we've worked with University of Montana to build. It's called the Rangeland Analysis Platform, and what that does, it tracks vegetation across space and time and allows us to see things really for the first time ever at biome levels. And so take on the left, the blue are intact grasslands, the red are grasslands that have been converted to woodlands through the expansion of woody species, whether it's eastern red cedar in the north or honey mesquite in the south. It's all about this, continued march of woody vegetation into grasslands. And so what we've seen is the red in the last 2 decades has converted over 100 million acres of grasslands to woodlands. Massive implications for wildlife. We document the fact that prairie chickens are, as one example, are very sensitive to increased fragmentation with trees. We've documented the loss of livestock forage. Neighborhood of 75% of forage is lost as these transitions happen. But for the first time ever, we've been able to quantify the scale at which it's happening and where. And so now on the left side of the graph, if you look at the primary driver of grassland loss in the Great Plains is conversion of grassland to tillage agriculture, cultivation. And so juxtaposed to that, though, for the first time ever, we recognize that this woody expansion is really on par with grassland loss due to cultivation. And so these are the 2 big drivers then that our frameworks are going to focus on, not the nickel and dime things, but the things that are the biome level drivers of loss and degradation. And so what does that mean, right? So let's go look a little deeper at the woody encroachment issue, to where on the right side, you're going to see from woodland transition, these are the areas that have already been converted from a grassland to a woodland. And if you move there to right, you'll see a gradation where in expansion, those are individual trees that you can visually see above the grass. The yellow area would be the places where a lot of new seeds or seedlings that are below the grass, where you might not even recognize you have a problem before it's too late. And then on the far right, you would have this intact grassland. In the past, we've always worked where we observe the problem, right? So where we see the forest where it used to be grass, or we see new forest coming in, that's where we would invest our resources collectively. And we would do brush management in those landscapes, while at the same time, maybe not paying attention to our backside and having dispersal and recruitment eat our lunch. And so those new seed sources were expanding at such a rate that we were continuing to lose the battle, even though we were fighting the war every day, or vice versa. And so what we've done through this framework is really flip the script, to where now, again, go to that green, right? That is where we find these intact grasslands. Defend that core, then grow the core, right? That's where the yellow and then mitigate impacts would be in the red. So it's about taking a brand new science-driven approach of putting the right practices in the right places to achieve these outcomes that we desire. And that's really at the heart of what we're trying to do here. The other big driver of grassland loss in the Great Plains is, again, like we mentioned, the cultivation. Fascinating looking at that situation where if you look at the map on the left, you'll see that Great Plains grasslands are colored red, yellow, and green based on cultivation risk, where red is high, green is low. If you juxtapose that on the right, with what's actually already been converted, you will see that most of those high and medium risk tillage have already been converted to crops. But what's happening is, even today, we're still losing about 1 million acres a year to cultivation. And the new fields that are being cultivated are lower in crop yields than the average. And so what's happening is, as we continue to still chip away at these grasslands and convert them to cultivated fields, we are now tilling and putting in production more and more marginal fields at huge cost to wildlife, carbon, and so forth. In fact, people find it surprising that the rates of loss, like in this northern region and what they call the prairie pothole region, the current rates of loss rival those of the loss of forest in the Brazilian Amazon. So it is a big deal. It's happening at a very large scale, and it shouldn't surprise anybody that the new Science journal that documented the bird loss had this particular region in these grasslands as kind of the poster child for measured impacts to wildlife. So what are we going to do about it? Right? What can we do about it? Well, first is understanding what's causing the current loss of grasslands to cultivated fields. And at the heart of this is really understanding our nation's largest conservation program, the Conservation Reserve Program. So real quick, for those of you not familiar with it, this was a program that was established back in 1985. Department of Agriculture, it's our sister agency, Farm Service Agency, has really done a phenomenal job taking formerly converted grasslands and restoring those and putting back grass green side up, and then provides that landowner with an annual rental payment to maintain that grassland. And those are short-term, 10 to 15-year contracts that ultimately expire and sometimes are extended or sometimes not. And so in the past, again, tens of millions of acres have been restored and maintained through this program. The bad news is that the acreage caps and the opportunities to re-enroll are just greatly reduced today. And as those properties come out of CRP, the landowners really have a choice. They can either cultivate those lands and revert back to cropland, or they can find another way to maintain the grass green side up and replace that lost income stream, right? But today, look at the bottom here. This is the take-home message. This outlook and that determination is so important because acreage exiting CRP today is the largest source of grassland loss in the nation. I'm going to read it one more time. Acreage exiting CRP today is the largest source of grassland loss in the nation. We have to recognize where we're losing grass if we're going to be able to solve it. So our frameworks are taking a new or novel approach to trying to proactively address this particular threat with the tools in our toolbox. What we're aspiring to do is retain grass exiting CRP by replacing lost annual payments from CRP with revenue generated from sustainable livestock grazing. And we believe there is incredible opportunity for widespread adoption, as currently only 5% of fields coming out of CRP are enrolled in another program. They just did a massive evaluation of tens of thousands of CRP contracts in the Great Plains and found that landowners are highly interested in retaining grasslands if only they have a way to replace that lost income stream. And in fact, that on their own, they were already retaining 58% of those lands that expired through the use of livestock grazing as the mechanism to replace that revenue stream. So again, this is also something that ties back to that primary ACOGs, right, with the climate goal of, first and foremost, our number one job out west in rangeland is to make sure we don't lose grass and rangeland to cultivation. That's our number one problem. So again, this is something that not only are we trying, but we're doing it in very strategic fashion where we think we're going to have the biggest benefit for wildlife, where we have communities that already want to work with us, and we have those intact cores that we'll be sewing up. On a very similar note, we have again, another tool in our toolbox called conservation easements. And these are legal agreements that we negotiate with landowners on a voluntary basis, in which we essentially purchase future development rights to a ranch. In this case, we're trying to prevent future conversion to subdivision or to cultivated farm fields and the like. And so these are very costly. They're very complicated partnerships put together. But what we've done through the frameworks is found just incredible rock stars and partnerships that have been able to take these concepts and put them into action, provide us a proof of action, proof of concept. And the one that we have for conservation easements is our partnership in the state of Montana, where over the last decade, they have been able to put together tens of millions of dollars with this incredible partnership that's conserved 250,000 acres perpetually of some of the most important intact landscapes that, again, not only provide for a future for these families, but also provide world-class wildlife habitat. They maintain, big game and other bird migration corridors and the like. And again, these are the types of things that are included in these frameworks. All told, in the Great Plains Grasslands Biome framework, our state conservationists have targeted roughly 10 million acres of on-the-ground conservation over the next 5 years. Primarily focused on those two threats, right? The big drivers of biome change, woodland expansion and land use conversion. These are goals that the state conservationists are using all of their resources with those of their partners to obtain, and ones that we will be working together to quantify and track progress and report back to partners. Here's where we're at. Here's where we'll be quantifying outcomes, so we can speak to, what benefits did we have to populations of wildlife? What benefits did we have to the underlying economics of ranchers? What benefits did we have to the climate adaptations and mitigation? So again, real excited to have these come to fruition. We will be announcing these shortly and releasing them shortly, so definitely keep an eye on that. But again, like Martin said, this is not something that's, quote, brand new for an agency. It's really a continuation of what we've been doing, but we're doing it in a much more deliberate and comprehensive fashion. So with that, I thank you again for your time today. We look forward to questions.
Good morning. Thank you for this opportunity to speak with you today. I'm Maggie Johnson, the Climate Adaptation Program Manager for the Association of Fish and Wildlife Agencies. Today, I'll be sharing with you some stories of on-the-ground adaptation actions taken by state agencies and their partners, underscoring the importance of working across boundaries. So first, we have to ask ourselves, what boundaries and why? As ecologists, we know that species don't adhere to boundaries, and we are also seeing more and more that climate impacts also know no boundaries. So even though we have a lot of artificial ways of breaking up the landscape, we must recognize the importance of looking beyond and working beyond at a scale that makes the most sense ecologically. The first case study I want to share is the Bees to Bears Climate Adaptation Project in Idaho. After decades of intense agricultural and hydrologic management, Idaho purchased land to create the Boundary Smith Creek Wildlife Management Area in 1999. Since then, management interventions have significantly increased waterfowl and big game production. In recent years, Idaho also began looking at ways to improve ecological management and enhance climate resilience and adaptation for species of greatest conservation need in the area. For example, snowpack depth and duration are decreasing, and this reduces summer soil moisture, impacting species dependent on those conditions, such as pale jumping slugs. So Idaho Fish and Game, in collaboration with Yellowstone to Yukon, developed a plan for climate-smart conservation in 250 acres of the wildlife management area. Their actions include restoring ephemeral flood cycles by planting native vegetation. This is essentially to re-engineer wetlands to benefit native species such as amphibians. They're also creating topographically altered pollinator habitat, and they're doing this through a series of excavated trenches to provide cool air refugia. And finally, they're reforesting the area with 60,000 native trees and understory plants to provide cover for grizzly bears and to improve soil moisture content and reduce air temperatures. The project is only a couple years in, so they can't say definitively if what they're doing is a success. However, through monitoring such as temperature, soil moisture, and solar radiation, they are seeing some results that indicate the structures are proving to be effective. They are gearing up for more monitoring soon, such as pollen DNA analysis, to see if pollinators are utilizing the native vegetation that they are restoring. If you want to learn more or reach out, I have the contact information and the website listed on the slide there. Next, I want to turn our attention to Florida. In Florida, with its highest point just 345 feet above sea level, we know that rising tides, coastal erosion, and increasingly violent storm surges are some of the greatest challenges facing the coast. To combat this, staff from Florida Fish and Wildlife Conservation Commission and other partners have launched a training course for marine contractors on living shorelines. Living shorelines can help coastal areas adapt and respond to sea level rise by reducing erosion, storing carbon, improving water quality, and providing fish and wildlife habitat, as well as promoting recreation. Living shorelines are great because they can act as a natural barrier to wave and can absorb as much as 50% of incoming wave energy, providing more resilience against storms than traditional hard shoreline structures like bulkheads. Last year, Florida launched the first training course for around 30 contractors. They review the benefits of living shorelines, discuss feasibility for placement, and provide specifics on implementation. They also follow up with maintenance and how to help landowners understand the effectiveness of implementing living shorelines. They focus on green methods such as oysters, mangroves, and marsh grasses, but also offer guidance on hybrid methods, seawall enhancements, and alternative products to boost resiliency for both coastal habitats and coastal communities. The course is a great way for engaging industry to ensure greener, effective solutions are being implemented throughout the state. The course offers continuing education units, and in the future, they hope to expand the program into a certification process. For now, they have all the contractors who have completed the course listed on their website. While there have been challenges for the course to pivot to an online platform due to COVID, they are still able to create opportunities for participants to safely visit field sites for hands-on learning. Florida is also in discussion with other coastal states that are interested in standing up their own courses. This is a really exciting program, and Florida hopes to continue to expand the program and are gearing up for their next course installment this April. For more information or for contact information, it is again listed on the slide. Now I'm going to talk about the Texas native fish conservation areas. There are 190 species of native freshwater fish in Texas, and of these, 90 are considered species of greatest conservation need. In the face of climate change, many of these species are increasingly vulnerable to ecological shifts, such as increased occurrence and severity of drought. Texas Parks and Wildlife is working to protect these species by targeting adaptation strategies for drought, particularly along arid rivers, both current and forecasted. Increasing drought affects both the timing and regularity of flows and water levels necessary to support spawning and other freshwater fish habitat requirements. In addition, there's a lot of complex interactions between climate change impacts and existing anthropogenic stressors, such as invasive species or river fragmentation, pumping of groundwater. And all of these things make it really difficult to parse out the relative magnitude of the climate effects. So to work in such a complicated and vulnerable space means taking a watershed level approach to freshwater fish conservation and management. Texas and partners developed the Texas Native Fish Conservation Areas Network. The network serves as a catalyst for collaborative, landscape-scale, and science-based stewardship of aquatic habitats. They work on projects such as restoration and preservation of riparian habitats, restoration of aquatic connectivity, control of invasive species, as well as the establishment of conservation demonstration areas. The work being implemented within the network represents both proactive and voluntary measures that enhance the resiliency and adaptive capacity of native freshwater fish. They began by developing mapping products, including species distribution models, multi-species aquatic assessments, and conservation prioritizations that were assembled by their partners at the University of Texas at Austin. Through this work, the network identified 20 native fish conservation areas to focus their efforts. Their goal is to achieve wild, naturally produced, self-sustaining populations of focal species within their priority watersheds, and to implement conservation practices that would provide broad-based benefits to local communities, such as water quality, enhanced productivity of working land, recreational enhancements, among many other benefits. Using this prioritization, the network has brought action to the ground through project-level initiatives, partnering with local organizations, landowners, and others. Since 2016, over 30,000 acres of the Texas Native Fish Conservation Areas Network has been preserved through conservation easements. Native fish conservation areas have also been selected as priorities for riparian invasive species control and riparian habitat restoration, with over 380 miles of riparian restoration conducted since 2016, in collaboration with over 460 riparian landowners. As for next steps, they are continuing to collaborate with local partners to identify additional project-based actions to include in the next revision of their State Wildlife Action Plan, which is scheduled to be completed in 2023. Some of the common takeaways or lessons learned in these examples include partnerships, and partnerships at all levels and at all scales. We also see landscape approaches, whether looking at watersheds or within particular geographies. All of these projects are also proactive. They are seeing changes on the ground, but also anticipating more changes down the road, and are implementing strategies now and tweaking as they go along. Finally, we see these projects really strike a balance between research and management. And this is again because managers recognize the need to do something now and adapt their actions over time. Adaptive management will continue to play a really big role in climate adaptation into the future. Some final thoughts to share for managers interested in taking climate adaptation actions to the ground. First, we need to reconsider conservation goals, not just the strategies and actions we implement. Second, we need to identify and include critical partnerships to make a project successful. So don't be afraid of crossing those boundaries and working in collaboration. Third, we need to ensure adaptation is being integrated into both new and existing planning and management processes. Fourth, we must act intentionally. Link the conservation actions you are taking with the climate impacts or expected impacts your state or jurisdiction is confronting. Even if the choice is to not change your management strategy, it needs to be the intentional choice for the most effective conservation and management. Finally, and perhaps the hardest of all, is to manage for change. Utilize adaptive management and other frameworks such as Resist, Accept, Direct to help you navigate these complex and challenging issues. Thank you again for letting me share some stories of on-the-ground adaptation. I hope these will inspire you to work beyond your boundaries, whatever they might be. If you have questions, feel free to reach out, and I look forward to discussing with you more. Thank you.
Thank you. Thank you to all of you who have joined us today for our live panel presentation after the information that we shared in our special session on climate adaptation. You know, as we started off to say, things are happening fast and the time to act is now. We've had a decade more of preparing, of digesting the science and planning. Now we're going to hear from across our panel and our speakers just how do we move from a plan to taking it to action. All right, we've had several questions come in to start with, and I want to start with one that is really intriguing. Okay, so this is about the taking the action, and this will differ depending upon which organization we're talking about. So, how did you get resource managers, communities to take action, to overcome and be comfortable with uncertainty? And let me start with Tim. All right, so talked about large landscape activities. That's a big bite. How do you NRCS get folks to take that first action step in terms of your sage grouse restoration activities?
Yeah, well, thank you, Cynthia, and again, thanks everybody for the time today to engage in this important discussion. One of the things that I'd like to point out at the beginning of this is the success of Sage Grouse Initiative as one of our first ever Work on Land for Wildlife efforts, launched over a decade ago out west. And if you follow that through that decade, you'll see that we had incredible support with the ranching community as far as participants, incredible support with the wildlife community and everybody in between. And it's been a sustained effort through that entire period where, collectively they've restored over 8 million acres of landscapes. And if I had to point to one single thing as far as what actually motivated people to do it, it was really this adherence to a shared vision of actually creating a win-win solution that truly did work for everybody, where we could restore that landscape and have these outcomes that people could benefit from, wildlife could benefit from, and the like. And also the fact that we relied on science to really quantify those outcomes, because it's one thing to talk about those acres and the number of participants. It's another to talk about the fact that we've increased population growth rates of sage grouse by 12%, or that we've increased, livestock forage by, 20%, or whatever the metrics are. Those are the things that ultimately matter to people and I think keep them going. So I think that shared vision and our focus on outcomes has really led to the ability to bring in a very diverse coalition and sustain it over time.
Okay, thank you very much. I'm gonna ask, so your organization and your efforts worked with private landowners, and so what you're sharing with us is that there was a problem out there and the group saw a win-win solution, so reduce the risk of losing something that was important. But I want to turn to Paul and say, you work with a different community across federal lands. How did you get folks to take that first leap of faith to start installing some of these structures for restoration in the same biome?
Well, similar to Tim's answer, I think it started with the fact that we had a collaborative process in place surrounding Gunnison sage-grouse, and we'd had a long working history, both working with our federal and state partners as well as private landowners. We get this a lot. We get a lot of questions because we're trying to export this technology to other places. It has to start with that trust, and I think the sage-grouse working groups that we had functioned together so long that we had built that initial trust. And so it was really interesting when Nature Conservancy first came up with the idea of bringing Bill Zeedyke and his technology to the basin. Our first two projects were not, in fact, on public land, but rather they were on private land. We had an agricultural landowner and then a landowner that had protected their property with a conservation easement both step up and say, we would like to volunteer our properties first. And it was really the private landowners who stepped up first. And then as the federal agencies saw both how the structures were going to be built and the results of the structures, that's when as those projects were taking place, that's when they started doing all the NEPA planning, and we ended up getting a candidate conservation agreement signed with the Fish and Wildlife Service for actions on federal lands. But it was really similar to what Tim described. It's that collaborative process that I think when we actually have effective collaborative process, local collaborative process on the ground, that's where we can see these programs take off.
Okay, great, thank you. So what I have heard from you, and I'll just say from also my participation in collaboratives, one of the things that keeps emerging is that we have an opportunity on private lands. Folks are willing to step forward and try something new. There's I guess perhaps a feeling of less risk there to try something new. And I think several of you pointed out in your talks that starting small is important. So let me look over here to Marvin and to Maggie. You also work across with state agencies, engagement with private landowners and programs. Maggie, you talked about the importance of easements on private lands for restoration, and Marvin, state action plans, work to bring good practices and resiliency to those private landowners. So talk a little bit about that engagement and what are some of the tips, techniques around working with private landowners to take that first step in your experiences and their willingness?
I'll let Maggie go first.
Okay, thank you. Well, that's a great question. And I think at the heart of all conservation is partnerships. That's really how we can leverage our funding, our resources, our expertise to get things done on the ground. And I think one of the really important points about partnerships and collaboration that I want to underscore here is that the need to have inclusive partnerships. And so making sure that we are reaching out to partners who may not be traditional ones that we've always worked with, but reaching out to those who may be new or underserved historically, that we can fold into the process and not only just say, this is what we want for conservation, but go to them and say, what is your vision for conservation? What are the impacts and challenges you're seeing on the ground, perhaps in your own, private lands, and how can we work together to accomplish some of these goals, to address some of these impacts? And so I think, Paul talked about building trust. And so the first step is reaching out and, trying to have those conversations with an open mind, trying to understand where other people are coming from and meeting them where they are. And that's really how you build trust. And the other point I want to make is that building collaborations is a long-term process, you know, and we know this about conservation. It's not a sprint, it's a marathon. And so although we always want to see things happen faster, taking some of those partnerships slowly is an important piece of building that trust and having that time to understand the challenges and the needs on the ground.
Thank you. Marvin?
Sure. Yeah, I would agree with everything Maggie said. Just thinking about forest landowners, I saw a statistic not too long ago from the National Woodland Owner Survey that indicated that most family forest owners really don't know a lot about, say, the value that forests provide for sequestering carbon. So I think, you know, the information's got to be credible, but it's got to be pretty broadly shared too. I think there's a pretty big education component to getting things done on the ground right now, so that landowners understand that there is an important role for their woodlands to play. The other challenge to that, though, is most of the family forest landowners don't own property of a size that really creates kind of a feasible project scale if you want to, for example, market for carbon sequestration. And so there's going to need to be ways to bring groups of landowners together, like everybody's been saying here, you know, have them develop a common objective, but also pool their lands in order, if for example, they want to enter the carbon market.
So there is a note here, a follow-up question for you, Marvin. Are there any regulations in place that would hinder the ability of a plan to achieve its full potential? How do you try to fix that to begin conservation efforts? Now, that's a broad question, and there are 50 states out there that probably have different approaches to that. But in general, what are you seeing in terms of across the board? Anything you mentioned, size of landowner, are some of our programs and the market opportunities for verified voluntary carbon credits require minimum numbers of acres, and it's very expensive. So what would be some breakthrough opportunities to encourage greater participation by private landowners with smaller acreages?
You know, I think there's going to be a role there for public agencies like state forestry agencies to lower the cost of participation by offering up inventories and verification, maybe some monitoring. There's private companies out there who kind of specialize in developing these carbon projects, but like you say, they can be pretty expensive for a small landowner. And I think there is a role there for public agencies to help lower those costs by, conducting some of the upfront work, management plans, inventories, those sorts of things.
All right, thank you. I want to turn over to follow up. There was Martin Lowenfish with NRCS. And we know that NRCS does have programs that allow for private landowners to participate and to receive payments for installing those practices that create a conservation or public benefit. So what about that? When we think of NRCS, you mentioned, working lands, agricultural practices. What about forests and forestry and the role that NRCS can play in providing these greater opportunities for landowners to manage and maintain forest lands?
Well, I think what you provided at the end of your question there, Cindy, was the right one to throw into any conversation with landowners, is that we look for the opportunities that are out there, not just for the resource, because we know that we need to be science-based when we're addressing any of these global or landscape scale challenges, that we need to be able to effectively deploy the technical practices on the landscape, but that we also have to understand that in addition to that opportunity for all the resource, there has to be an opportunity for the landowner. And I think Marvin was talking about that as well, like making access to the carbon markets available. And we've certainly talked about that. Tim had this great diagram that the target of opportunity is that intersection with the voluntary programs is that intersection between, where the wildlife need is, where the, broader resource need is, and where the producer interest is. I think what we didn't talk about that is that core, that overlapping core has the potential to expand. And we talked about this, about, where do you start? How do you adopt? Success breeds success. And that if we can then, find the sweet spot to really target our efforts, then we can work with landowners who can share with their neighbors. And whatever we do as a group of professionals is way less convincing than, rancher talking to rancher or neighbor talking to neighbor. So that's what we, would get back to that opportunity question. How do we merge that science with the production opportunity and the interest of the producer, and make sure that there's this really stakeholder driven process that where the success can be fed through that network?
Okay, thank you very much. That's a great segue to a question for you, Dan Isaac, as I'm reading through and there's some interest here. All right, so we've heard that building a collaborative and holding that is important. And we've heard that, decisions need to be based on good science and information. So how does one bring science into this group of decision makers, land managers, landowners, potential collaboratives, to stimulate action? What you've had experience with that, of bringing things down to making it accessible and communicating it. What were your lessons learned?
Yeah, great. Thank you, Cindy. Our experience in working with, primarily native cold water fishes in the Western United States was that a lot of different groups that were focused on that group of species were collecting similar types of data, or they had interests in many of the same things, but they weren't necessarily communicating very effectively. They weren't sharing data back and forth. And so there was a lot of redundancy in certain places and then missed opportunities in others. And so our approach in trying to figure out a way into helping all their efforts was to basically use the technical expertise that we had within the Forest Service to complement, many of the on-the-ground activities they were already doing. And so we formed a database team that could integrate and pull together the disparate data sets that dozens of different state, federal, tribal agencies were collecting, and shared that broadly then. So everyone had access to it, built higher resolution climate scenarios so that we could paint the thermal information on the landscapes that they were working in and formatted that information so that it was easily accessible to everyone. And that then gave all these different groups a set of high resolution common maps that they could share and use as a basis for their discussions and decisions about where they want to proceed with restoration projects. And the other part of that then too was that in terms of the engagement with those groups, they were collecting many of the temperature data sets that we're using to feed into this database. And so, it wasn't that scientists had gone off and created a research project and then we're trying to get people to use it. We were just adding value to the data sets that they had already collected. And once that process was up and running, then, that got them excited about the value of their data, and they also identified new opportunities to collect additional data in ways that would make what we had already more accurate by filling in gaps.
So, what you're telling us is there's a lot of data out there, a lot of different people collecting data, incredible data. We just need to bring it all together. So I love this concept around crowdsourcing, making data accessible through more of a contemporary lens. I want to segue into a sort of a different question and sort of following through some of the interests that I see in the chat. In the past, we've had a lot of science stand up and, suggest, to to landowners and managers what needs to be done to address climate change. And so it's confusing sometimes. And so part of the confusion, I think several of you brought up, is where are trees good? How many trees can we grow? What do we do with those trees? It's this tension between sequestering carbon through natural resource management, and then dealing with trees in the right place, right? So there is this realization, that in the past, science has driven society decisions, but now we're seeing a whole different movement of society driving science. Any comments on that? I just want to introduce something that's a little, contemporary in your thinking. So I've heard a lot about collaborations. I've heard about the need to communicate the science and information to people that are being affected, for folks to understand that. Maggie, you talked about the importance of making sure that you're inclusive and that the community and folks that are affected have a voice in the decision and the action. So that's like society driving, to the science or the needs, the applications, how you lean in. Anyone volunteer? Raise a hand. Paul?
Yeah, we're working with a broad array of people, a broad array of philosophies. I think here in the arid West, water drives everything. And so if we focus our conversations on water and restoring water tables and the benefits that can provide, whether it's water tables on public land that directly benefit sage grouse grazing communities, whether it's the benefits of longer base flows, better water quality, lower water temperatures on private lands. Matt Vasquez described, I think, really well, that there was a particular rancher that we've worked with for a long time. And he's a very stoic guy. He's very quiet, he listens, and he doesn't talk a lot. And Matt described the day that they were up on the forest boundary between his private land and Forest Service land. We'd done a large project that spanned that fence line. And he described the rancher's reaction to what he was seeing for the first time in his life, seeing water flow down a drainage that his dad had told him had water in it historically. But seeing that water cross onto his fence line, and Matt described him as giddy. He was laughing. He was his emotions were right there on the surface, and it was joy, it was delight. And so rather than getting hung up on the veracity of climate change or science, what we focus on is water and results. And I think if we find those commonalities rather than the things that divide us, we find the things that we agree on, it's much easier to work through these controversial issues. And again, that's built on that trust that we forged early on in the process.
Thank you very much. So speaking about, okay, Tim?
Yeah, I couldn't agree more. And I maybe building on that a little bit too, I think there's this other broad pattern in conservation right now that's moving away from the simplistic view of the world where, like, take climate and a tree. So tree sequesters carbon, therefore it's inherently good, right? So taking that sort of a simple approach and now recognizing more of the complexity associated with each biome. And so rangelands, we get this question a lot, right? Where the example that I was showing is how we have a tree, which according to our simple model would be good for carbon sequestration. But the problem is it's growing in a rangeland setting, which by definition should be a treeless, setting. And so all of a sudden, I think really understanding and appreciating the diversity and what should be on the land in these certain biomes and managing for that, each of by doing that, I think what it does, it makes us think a little bit deeper and think about the more holistic long-term process that rangelands actually take carbon from the atmosphere, store it very deep in the soil. And there's these processes that we want to maintain, which then give life to all of these other diversity of critters and ultimately people and so forth. So I think that's also moving forward going to be our biggest challenge, is to really, again, focus on those biomes and appreciate the diversity and the complexity within there and avoid the temptation just to go, whether it's threatened endangered species, whether it's climate, whether, whatever it is, I think it's going to be important for all of us to keep going back to that biome worldview.
Thank you. Thank you. I'm going to segue here towards the end and get back to the people question. So I know there's been tremendous engagement across a lot of different entities, both local governments as well as communities. I think Maggie, you and Marvin talked about that, particularly from a state agency point of view, and those important connections that state agencies have with more local communities and those local governments. And so we've mentioned, let's say, stay on the theme of water. Water is life. Too little is not good, and too much is not good. So Maggie, you want to talk about we have Florida. We have a high urban population in Florida living along the coast. What about those areas with people and society and science?
Yeah, I mean, that's a great question. And again, I think it comes down to reaching out to those communities and understanding their challenges. But also, I think it's important for state agencies and these collaborations to message how the work that they're doing actually affects these communities. I think in the past, there's been a disconnect where we see those who are working on, forestry projects or wildlife projects as, this is a separate thing that doesn't involve my community, but it does. It matters for clean air and clean water and clean, having a healthy, resilient ecosystem and providing those services like, buffering your coastal community from a hurricane or from flooding. And so I think we need to really focus on how we reach out to those communities and the messages that we're sharing that connects their community to the work that we're doing on the ground for natural resources.
Okay, thanks. Well, we're reaching the end of our time together. And I want everybody to make a real quick comment, and then I want to ask Marvin to wrap as our co-leader in putting this together. So, very simply, if from your point of view and your experience, if you could do one thing to more rapidly see for adaptation to more rapidly infuse throughout our systems to get more work done, what would that be? And I'm just going to start with my little Hollywood square here. We'll start with Paul.
Well, I wish I had something broad and philosophical, but it's money. I mean, if we could to build capacity, when Nature Conservancy developed the model that we use to prioritize our projects, they identified in the Gunnison Basin alone 32 HUC 12 watersheds for us to work in. At the rate that we're doing it, it's going to take us 60 years to do it. So if we're going to actually be able to do this on a landscape scale, we have to increase capacity, and ultimately that comes down to manpower.
Okay.
It comes down to money.
Great. So in a word, we need to increase and diversify our investment portfolio. Okay, Tim.
I think we need to increase the awareness and the association that our society has to their own landscapes that are in America, and to give them tangible things they can do that will make a difference. Like Paul's talking about, those low-tech structures, that's something anybody can do anywhere and have a meaningful change, but it's all about keeping it simple, having the appreciation, and giving them a lever pull to make a difference.
Okay, thanks. So education and tools and things to do. Translating. So translating science, very quick. Dan?
Yeah, I think for us, it would probably be more case histories actually showing how populations are responding in the wild, just so that translates it to something really concrete that people can see instead of model projections.
Proof of concept. And Martin?
Well, certainly agreeing with everything everyone said so far, but I think there's a tremendous amount of information out there, a tremendous amount of good science that, there's always opportunity for more, but our challenge is to bring all that information and that actionable data into a framework that people can use.
Translating it down for use. Maggie?
I would say engagement at leadership levels to empower staff and those on the ground to do the work.
Okay, passing it down and getting to work. And Marvin, I'll let you close out.
Well, thanks, Cindy. Thanks for involving the state foresters in this. I'm speaking on their behalf, but I would close with one thought, and that's there's a big marketing effort that needs to take place. In essence, marketing is convincing people to do something because they feel like it's in their own self-interest. And I think that's where we need to be headed with a lot of these issues, is convincing people that acting on climate change is very much in their own interest. So thanks a lot for putting this together.
Thank you, and thank everyone for participating today. And thank you joining us as well.